In a German town, a deadly secret hid inside a simple sausage. It was an invisible poison that stopped life itself. People fell ill with a strange creeping paralysis. Doctors were baffled, calling it the sausage poison with fear. A young physician, Justinus Kerner, became obsessed with the mystery. He believed the poison held a powerful secret. Kerner painstakingly documented every symptom, every detail. He was the first to describe botulism with chilling precision. He hypothesized that toxin works by interrupting nerve signals. A message sent from the brain but never received. But isolating the source of this invisible killer seemed impossible. For decades, the mystery deepened across Europe. Then, in Belgium, a funeral feast turned tragic. A single contaminated ham held the next crucial clue. Scientist Emil van Ermingem raced to the scene. He would find what no one else could: the bacterium itself. He isolated a tiny rod-shaped organism from the ham. He named it Clostridium botulinum. This was the culprit. The microscopic factory producing the world's most lethal neurotoxin, 1 gram of which could kill millions. The discovery was terrifying. Governments saw its potential not for medicine, but for warfare. The poison was now known. But could this fearsome power to paralyze muscles ever be used for good? The great gamble began here. What if this immense power could be controlled? The risk was death. The reward? A medical revolution. During World War II, American scientists undertook a dangerous task: purifying the toxin for research, hoping to create an antitoxin. A key figure was Dr. Edward Schantz. He successfully crystallized the botulinum toxin type A for the very first time. This pure crystalline form was stable. It meant the poison's dosage could finally be measured with precision. Control was everything. A dose too large was lethal. A dose too small was useless. The margin for error was non-existent. The question shifted from what the poison did to what it could be made to do. It targeted the nerve-muscle junction. This precise action suggested a new path. Could it treat conditions caused by overactive muscles like spasms or tremors? An ophthalmologist named Alan Scott read the research. He was treating children with strabismus or crossed eyes. Surgery was invasive and often failed. He wondered if he could simply weaken the overactive eye muscle instead of cutting it. He needed Dr. Schantz's purified toxin. After years of petitions, a tiny, precious vial finally arrived at his lab. He began careful experiments on monkeys, perfecting the dose. The results were astonishing. The crossed eyes straightened. The risk of human trials was enormous. A mistake could cause blindness or worse. But the potential reward was sight. In 1977, he received FDA approval for human trials. The world's deadliest poison was about to become a medicine. He called his new drug Oculinum, meaning eye aligner. Its purpose was singular, its future completely unknown. This was the turning point. The poison was no longer just a weapon or a threat. It was a tool. But how would this highly specialized eye treatment become a household name, known for something else entirely? Dr. Scott's Oculinum was a success. Patients with uncontrollable blinking and muscle spasms found relief for the first time. A pharmaceutical company named Allergan saw the potential. In 1988, they acquired the rights to Oculinum. They knew the name Oculinum was too narrow. They rebranded it, coining a new name for a broader future: Botox. The story then takes an unexpected turn, thanks to a Canadian ophthalmologist named Jean Carruthers. She was treating a patient for eye spasms with Botox. The patient made a strange request: inject her forehead. The patient explained that when her forehead was treated, her frown lines disappeared. She looked less angry, more serene. Dr. Carruthers was intrigued. She discussed the discovery with her husband, a dermatologist named Alistair Carruthers. They realized the implications were huge. This wasn't just about medicine. This was about aesthetics. They conducted the first clinical trials for the cosmetic use of Botox, even injecting themselves to prove its safety. The poison that once stopped hearts could now halt the appearance of time on a person's face. They published their findings in 1992. Initially, the medical community was skeptical, even scornful of the idea. But the results were undeniable. A new industry was quietly being born from this serendipitous discovery. Allergan, the parent company, was slow to embrace the cosmetic angle. Their focus remained strictly on therapeutic uses. Meanwhile, the toxin was revealing other medical talents. It could treat migraines by relaxing tense head and neck muscles. It helped people with excessive sweating, blocking the nerve signals that activated sweat glands. Its applications grew. It could even calm overactive bladders. The poison's ability to selectively silence nerve signals was a master key. By the late 1990s, the cosmetic use of Botox was an open secret among dermatologists and their celebrity clients. Allergan finally saw the writing on the wall. The demand was undeniable. The market was potentially worth billions. They began the long, expensive process of seeking FDA approval for the treatment of glabellar lines, frown lines. The trials were a resounding success. The evidence gathered by the Carruthers and others was now official. In April 2002, history was made. The FDA officially approved Botox cosmetic for wrinkle treatment. The secret was out. The world's most infamous poison was now the world's most famous beauty treatment. But this success raised new questions about beauty, aging, and the desire to control our own appearance. The science was elegant. Tiny amounts of the toxin blocked acetylcholine, the chemical messenger that tells muscles to contract. No contraction, no wrinkle. The muscle simply relaxes, and the overlying skin smooths out. The effect is temporary, lasting 3 to 4 months before the nerves create new pathways to the muscle. This temporary nature was key to its commercial success. It ensured patients would return again and again. An entire ecosystem of clinics, practitioners, and training programs emerged seemingly overnight. An empire was built. The journey from a German sausage to a multi-billion-dollar industry was nearly complete. Driven by science and serendipity, researchers continued to explore its potential, finding it could help with cerebral palsy in children, reducing muscle spasticity. It was even being tested as a treatment for depression, based on the facial feedback hypothesis. The theory suggests that if you can't physically frown, you might actually feel less sad. A controversial but fascinating idea. Competitors emerged, creating their own versions of the botulinum toxin. But Botox remained the dominant brand, the original. Its story became a case study in medical innovation. How to tame a villain and turn it into a hero. The key was always the dose. The difference between a poison and a medicine is simply the right amount. This principle, championed by Paracelsus centuries ago, found its ultimate expression in the story of botulinum toxin. From a feared killer to a precise healer, its journey defied all expectations. A medical paradox solved. The poison had been mapped, its secrets unlocked. But what was the grand design it revealed about us? It showed our relentless drive to understand and control the natural world, even its most dangerous elements. Now, the final act. How did this scientific marvel reshape our culture and our very idea of aging? The grand design was complete. Botox was no longer just a drug. It became a cultural phenomenon. It became a verb, a punchline, a status symbol. It reflected a society increasingly focused on youth and perfection. The lunchtime procedure normalized cosmetic intervention. What was once radical became routine for many. From Hollywood elite to suburban parents, the patient demographic exploded. The poison had been fully democratized, but its reputation remained dual. To some, a miracle of medicine. To others, a symbol of vanity. The story, however, doesn't end with a frozen face. It echoes in the future of medicine. Scientists are now designing new designer toxins based on its structure to deliver drugs directly to nerve cells. From a sausage in Germany, a chain of events was set in motion that continues to reshape our world. It's a powerful reminder that within our greatest fears can lie our most profound discoveries. Every stone, every toxin, every forgotten story carries a lesson. We only need to know how to look. The journey of this poison shows how curiosity can transform a villain into an unlikely hero for millions. Countless stories of innovation are waiting in the archives. Continue your investigation with our next chronicle.